This video is just to discuss whether complex numbers follow all the properties which a real number system follows. So here we discuss mainly the properties of addition and multiplication and regarding additive inverse and additive identity and all that. So first one we discuss is closure. So when we add or when we multiply two complex numbers, is the sum and the product, do they belong to C? Yes, the answer is yes, because sum of two complex numbers, how do we do it? Adding the real part separately and imaginary part separately. So the result you saw, it's again a complex number. And same thing when we multiply also, you already saw how do you find the product of two complex numbers and how the answer will be again a complex number. Similarly, commutativity. The given complex numbers can be added in any order, because addition of complex numbers again involve only the addition of real parts. Similarly, multiplication also. So automatically it will follow commutativity. Associativity. Associativity always involve addition or multiplication of three terms. So if you take three complex numbers and add them in any order, there is no difference in the answer. Addition can be performed in any order. Same way, multiplication also can be performed in any order. The next one, regarding the identity, existence of identities. So generally we say 0 is the identity element in the real number system, because any number added to 0 will result in the same number. And this is true in the case of complex numbers as well. So for complex numbers also, additive identity is 0, and 0 can be very well explained as 0 plus 0i in terms of the rectangular representation of a complex number. Then in multiplication, you know, the number 1 is the identity element, because any number multiplied by 1 you get the same number. But 1, how does it belong to C? You can write 1 as 1 plus 0i. So it has a rectangular form and hence it belongs to the system of complex numbers. And as to that matter, every real number also belongs to complex number system, as you saw in the case of 1. You can write 5 as 5 plus 0i, minus root 3 as minus root 3 plus 0i, etc. So when the imaginary part becomes 0, the number becomes purely real. When the real part becomes 0, the number becomes purely imaginary. For every complex number Z belonging to C, you can always get a minus Z belonging to C, so that when they add, you get 0. Because if Z is minus 2 plus 3i, think of 2 minus 3i, their sum will be 0, is it not? So for every Z, you will have a minus Z. Similarly, in the case of multiplication also, for every Z, you can always find 1 by Z. Exception is only 0. So if Z is a non-zero complex number, 1 by Z will always exist, and in previous videos I have already discussed how to simplify 1 by Z and get it into rectangular form. Similarly, complex numbers always follow distributive property, the left distributivity of multiplication over addition, or the right distributivity of multiplication over addition. Similarly, you can always verify that complex numbers obey the laws of indices, namely a power m into a power n is a power m plus n, a power m whole power n is a power mn, a power m by a power n is a power m minus n, etc.